Alright, welcome again to the second problem. So here it says write a C program which takes a number n from the standard input and print the following expression. 0 equals 0 plus 0 recursively. And the depth depends on n. So n is a parameter given to the function. So for example, if the user gives us 0, then we have to print 0 equals 0. If the user gives us 2, we have to print 0 equals 0 plus 0 between parentheses plus 0 plus 0 between parentheses, and all of them are surrounded inside parentheses. So you can see here the level, the number of repeated subproblems depends on n. So if it's 3, for instance, we have the same output of 2, but it is multiplied by 2. So we're going to print the subproblem of n equals 2, and then the operator of plus, and then the same subproblem of n equals 2, and then we're going to print the parentheses left and right. So you can see here that every problem is defined of itself. So f of n is defined by f of n minus 1, f of 3 is defined by f of 2, and f of 2 is defined by f of 1, and so on. The only base solution that we know is that if n equals 0, then basically we have to print 0. Otherwise, we're going to define the problem by versions of itself. So basically we're going to create a function called f. So it's function called f. It takes an integer n, and whenever we call this function, what we want to do is, well, let's define it here. So if n, so if the integer n equals 0, well, in that case, all we have to do is to print the number 0. That's it. Otherwise, the problem is defined in terms of itself. So we have to, the first thing we have to do is to print the left parentheses. So let's print a parentheses. So that's an open parentheses. And then we're going to print the operator plus. And then we're going to print the closing parentheses. All right. But whenever we open a parentheses, inside a parentheses and the plus operator, we're basically going to call for the subproblem for f of n minus 1. So f is going to call itself with n minus 1. And same thing here, it's going to call itself with f minus 1. So if we have, for example, f equals 2, so let's execute this function. So 2 is different from 0, so we're going to print an opening parentheses. So that's an opening parentheses. And then we're going to call f of n minus 1. So that's f of 1. And f of 1 in turn, 1 is different to 0, so f of 1 is also going to print a parentheses, an open parentheses, and then it's going to call f of n minus 1, so that's f of 0. Now 0 equals 0, so this will basically print the number 0. And then once this function returns, so it'll return to f of 1. Now we reached this this instruction. We're going to quit the function call to print the plus operator. So that's a plus. That's a plus. And then basically we're going to call f of n minus 1 once again. So we're going to call f of 0. Now again, f of 0 equals 0, so we're going to print 0. And then we're going to quit. And then finally, after we quit the function call, we're going to print a closing parentheses. So, and then after we print the closing parentheses, we're going to leave the function, we're going to quit the function. So f of 1, we're going to quit from f of 1, we return to f of 2. f of 2 has executed f of 1. So now it's going to print the plus operator, so that's a plus, and then it's going to call f of 1 once again. So it's going to call the second f of 1. And again, f of 1 is going to print an open parentheses and then call f of 0, and then f of 0 is going to print 0, and then it's going to return, and f of 1 is going to print a plus operator, and then it's going to again call f of 0, which will print 0, and then when we leave f of 0 back to f of 1, so it's going to print its closing parentheses, so it's going to print its closing parentheses, and then after we leave f of 2 will also print its closing parentheses, and then we're back to the calling function. So that's basically the tree. That's what's going to happen when we call f with 2. If we call it with 3, basically this same tree will be just a subproblem. So there's going to be an f of 2 here and an f of 2 just next to it, and there's an f of 3 calling both of them. So basically that's, we call it a two-level recursion because every function has to call itself twice for two subproblems. All right, so let's code this. So back to code blocks. So we said that the function is called f, and I'm going to give it n, and basically we said that if n equals 0, we're just going to print 0. Otherwise, we're going to print an opening parentheses, so that's an opening parentheses. And then we have to print the plus operator, and then we're going to have to print the closing parentheses. And then inside the opening parentheses and the plus, we're going to call for the subproblem, the first subproblem, that's f of n minus 1. And then here we call for the second subproblem. Let's make this a little bigger. So that's f of n minus 1. And, well, that's it. So here let's just declare variable n. I'm going to give it 3. And I'm going to call the function f with that n. And now when I hit compile and run, as you can see, it prints out the expected output. And here, of course, I have to add this printf 0 equals message before calling the f function, and it's going to print the expected output. So basically, that's how we solve this problem. See you in the next video.